problem, smallest subtree with all the deepest nodes. So given a binary tree, so which has the node as root. So here some definitions are mentioned. The depth of each node. So for a tree, so the depth is defined as the shortest distance to the root. So we have to return a smallest subtree such that it contains all the deepest nodes in the original tree. So we have to return a subtree of the tree, original tree, so that the smallest subtree, so that it has to contain all the deepest nodes in the tree. So a node is called the deepest if it has largest depth. Means it can be a leaf node. It is a leaf node which has more depth compared to other leaf nodes. So the subtree of a node is a tree consisting of that node plus the set of all descendants of that node. So we have to give a subtree of that node. So let's understand this by an example. So here, so this is a binary tree where the root node is 3. So this is the root node. Okay. So we have to find the deepest nodes first, and we have to find a subtree, the smallest subtree, so that all the deepest nodes has to be present in that subtree, and it has to be smallest. Let's find out this. Okay. So let's see what are there. So if you consider the root, the distance from that root to the root is 0, so depth is 0 here. So I'm writing this one as 0, and here, so if you go into the another level, the children of that root, so the depth will be 1 for 5, because the distance between 5 and 3 is 1. 5 and root is 1, and the depth is 1 here as well. And if you go to the children of the node 5, these are 6, which are the depth 2 from the root, and 0 and 8 are also at depth 2. So there are no children for 6, node 6, and for node 2 there are 2 children. So these are at depth 3. Okay. So for every node we calculate the depths. So if you consider, so this particular binary tree, so the largest deepest nodes are 7 and 4. So 7 and 4 are largest. So we have to find the subtrees related to these which contains the 7 and 4. So let's find out. So let's consider 7 as a subtree. The nodes formed by taking root as 7 as a subtree. So it doesn't consist of all the deepest nodes. 7 consists of 7, but it doesn't consist of 4. So this is not a correct subtree. Let us consider 4. This alone won't be a subtree because it doesn't consist of 7. But let's consider root as 2. The subtree formed by this root is this thing. So this consists of all the subtrees, all the deepest nodes. So this can be one subtree, 2, 7, 4. This can be one subtree. So next one, let's consider 6. So 6 as a root of a subtree, it doesn't consist of all the deepest nodes. So let's consider 5 as a root of subtree. So it contains the 7 and 4, the deepest nodes. So this can be one subtree. So let me write that. So 5 consists of 6, 2, 7, 4. This is one subtree. Okay. So let's consider 1 as a root of subtree. The subtree is this one. This doesn't consist of deepest node 7 and 4. So 0 doesn't consist of 7 and 4. 8 doesn't consist of 7 and 4. Taking 3 as a root of a subtree, it consists of 7 and 4. So the subtree is the entire tree. So let me draw that one as well. 3, 5, 1, 6, 2, 4, 0, 8. Okay. So these 3 are the subtrees in which the deepest nodes are present, which are 7 and 4. So out of these 3, so the smallest subtree is this one. So we have to return the root node. The root node is here is 2. So we have to return the node 2. So this is what the problem is about. So let us solve another different type of examples, and let us go into the intuition behind it, how to solve it. Let's see how to solve these uh, inputs for this first one. So you can see that, so this is the root, and we will find the deepest nodes. So this is at depth 0, these are at depth 1, these are at depth 2. So deepest nodes are 4 and 5. So we have to find the subtree which consists of these deepest nodes. Let's see which one. So if you take 4, it won't be containing all the deepest nodes. Similarly 2, if you take 2 as a root of the subtree, it only consists of 4, it doesn't consist of 5. So we have to find the subtree which consists of all the deepest nodes. So here also 5 won't be, and 3 won't be the root of the subtree which consists of all the deepest nodes. So the possible way is, if you take root as 1, then it consists of all the deepest nodes. The answer is the root node. 1 minute time. The root node for a subtree is 1. So let's consider the second example. So here, so we have to find the deepest node. First we will find the depth of each node. So this is at depth 0, this is at depth 1, this is at depth 2. So the deepest nodes are 3 and 4. So we have to find the subtree which consists of all the deepest nodes. So 3 doesn't be the root of the subtree because it doesn't consist of 4. 4 also not the root of the subtree. So let's take 2. 2 is the root of the subtree, which can say consist of all the deepest nodes. So we have to return the smallest one. So here we have to return the root node as 2. Okay, so let's consider this example. So here it is at level 0, level 1, level 2, level 3. So level of depth was the same. So we have to, the deepest one is this one. So we have to find the subtree, so which consists of all the things. So if you find this thing, the observation is, if you take this one as a root of subtree, it also consists of 4. So it is also small as well. So here the root node we have to get output as 4. So we have to find the smallest subtree which consists of all the deepest nodes. So what can be the intuition behind it? Let's see the intuition behind it. Let's find out the observations what we can see from the above examples. Let's consider this example. So if you see, you can tell that this one is the subtree. So how you can tell that this one is the subtree? So let's see. So if so considering these two subtrees, so the depth of, this subtree, the height of this subtree is 2, because there are 2 layers. 2, here the depth is 1. So for every, so if I want to solve, so you can observe that. So if left depth is greater than right depth, so if this is the case, if this depth is greater than this depth by taking any subtree of a particular level, so these are at the same level. So if you consider these two, their depths, how much height of the tree, or you can say anything. So if these two, if you compare, and this one is left depth is having more compared to right depth, then we can conclude that the deepest nodes are at left, right? Okay. So similarly, if right depth is greater than left depth, then we can say the deepest nodes are at right. So consider, let's consider the level. So let's consider this level. So where the left one, same level one, where the left one and right depth having 0. These are at level 1. So having a depth as same. So what happens if left depth is equal to right depth? Then there might be the deepest nodes. Then can go to the before one. Means we have to find the common ancestor of these two nodes. So we have to get the common ancestor of left and right. Okay. Hmm. So how can so there are so many common ancestors for this. So this one is common ancestor, this one is common ancestor, so we have to find the lowest common ancestor. Okay, so here we are going to every node. So we are going to every node with respect to that level. So we will find that particular left node and right node of a particular node, and we will just see if a left node depth is more than right node depth, then deepest nodes are present on the left. So we can store the data of the node. So how we can solve? We can solve by recursion. We can go from bottom to up. So we will do bottom to up approach. Let's see how we can solve this. So what will be the recursive function? So the function has to take the root, so any root, and it has to give the depth of that root, the tree formed by that root, and it has to give the root of, let's say, the node in which the lowest and the deepest nodes are present. So it has to result that it has to give the node in which the tree contains the deepest nodes, right? Okay, so what it will give, let's understand by this example as well. Understand this by example as well. So if you take this example, so if I give the 1 to that function, it has to give the depth of 1, that depth of that 3, which is 0 1 2, that is 2, and it has to return the node in which the subarray formed by that has the deepest nodes. So it has to return 2. So let us call that as a 2 star, which is the node 2. This is the depth 2. So it has to return like this. So we will go for bottom up approach, means we will start from down and we will reach till top, and we will find it is a divide and conquer problem. So we can use DFS algorithm for this. So let us understand the pseudocode and let us solve this problem. The question is we have to find f of 1, means it has to give two outputs. One is the depth of 1 and another one is the node in which uh, the it is a root, and it has to be it has to contain all the deepest nodes. Let's see, we'll go from top bottom. Let's write the pseudocode how we can do this. So we have to solve for f of 1. Let's see how we can solve for bottom up approach. First we will solve for f of 4. So we will calculate the left node of f of 4. So there is no left. So there is null present here, and there is null present here. So there is no uh, nodes present here. So we will return 0. That means the depth is 0 of this node, and we will return null because no such a node is present. So and here it will also give 0 0. So it will check. So based on these two, so left child is returning left depth. So left depth is 0, and right depth is also 0. So if the left depth and right depth are 0, so we will go for ancestor. Common ancestor is 4. So we will complete this, and we have to increase the height as well. So what we will do is, so it will return height of 1 and 4 as an common ancestor because the roots are not having any depth, the depths are same. So okay, this one has returned, means f of 4 will give 1 as the depth of 4, and the common node is 4 itself. Okay, then what f of 2 will do? So this one has null, and then the null will return as 0 and null. So this will check the left node is having the depth of 1 and right node is having the depth of 0. So it will again check what is the left depth. Left depth is 1, which is greater than the right depth. Then so what it will do? So it will return 2. 2 is nothing but the height. It will increase the height by 1, and based on this comparison it will return the left one. Left one is 4, so 4 is the left one. Okay, so then it will call f of 3. Let's find f of 3. So f of 3, so f of 3 also not having any children, so they both are null. So the null pointers will result as 0 and null, 0 and null. So since the children are having depth as 0, so it will again check. Let me erase all the things here and let me go into the third one. So what it will do here, also the left depth is equal to right depth, so it will give the common ancestor. The f of 3 will return the common ancestor. So the common ancestor is 3 only, because these two came from 3 and it is lowest as well. So this will return a depth of 1, because 0 will be increased to 1 and the common ancestor will be 3. Okay, so these functions are completed. Then now, so we have to calculate f of 1. We have to calculate f of 1 based on f of 2 and f of 3. So this is a recursion. It is backtracking actually. So how we can find f of 1? So we will see the left node, depth of left node. So the depth of left node is so left depth here is 2. So you can find the left here is 2 and right depth is 1. So you can find that left depth is 2. So right depth is 1. So left depth is higher than right depth. So what these two will return? These two, if left depth is higher than right depth, then this part is having the deepest nodes. So it will return the node which is 4. So 3 comma 4. So 3 is the depth, 4 is the node which in which it is a root, and the subarray formed by the subtree formed by that node has the deepest nodes. So f of 1 will result give 3 comma 4. Okay, let us see the pseudocode. I think you will understand this problem. So if you can try, you have to try with another examples as well. And let me give the pseudocode, and after that you can try, and we will code it up in C++ as well. So let's write that pseudocode. So there is a function which has to take the root, and it has to return a pair, so which is an integer and the one node, a tree you can say. So what it will do, what this function will do. So if we will write the base cases. If root is a null, so what it has to return? It has to return depth of 0. It has to return the answer of that node is null. Okay, what if it didn't the root is not a null? So it has to go the left part and the leftmost part, and it has to go to rightmost part, and it has to backtrack all the values. So that's what we will do. So first we will go to the left part. So left, let's say left is equal to, we will call function left, and right function root of right. Then it will go to the left and right, so recursively. So then we will write the conditions. If so left, so left here is a pair, here right also is a pair, because it will return a pair. So left dot first, left dot first is the depth. If left dot first is greater than right dot first, then what it has to do, it has to return left dot first plus 1, because the depth of that root is increased, and it has to return left itself, because left is the correct one. And the second condition is, if left first is less than right of first, so it has to return. So considering height is right of first plus 1, increasing 1 because and right, because right is the one having the subtree which is having more deepest nodes. So if both the conditions are not true, then they the depths are same. So we have to return the ancestor of that. So ancestor is the root itself. So return, we have to return height as, so since depths are same, we can take left dot first plus 1 comma the node itself, because so the depths are same, the left depth and right depth both are same, so we have to return the ancestor which is the root itself. So this function will return, so this is the completion of this function. This function will return the corresponding answer, the corresponding root, the corresponding node, and which is smallest, because when you see this example you can understand. So here 4 is the smallest, so this one is carrying from here to here. So this is how the methodology works. So we will code it up, and let's code it. So how we can code it, let's see. So we have to return a tree node. So first we will define a function, so it has to return a pair integer value in the tree node. Let's call as a function f, some function, and it has to take root. Okay, so if root is equal to null, it has to return 0 comma null, right? Okay, so we have to create a pair. So if it is not, we have to create a pair left as so we have to call the function root left, and we have to go right as well. Right is equal to function right. Okay, so if anything, if it is return, then after this return statement is completed, we have to check. So if the left dot first is greater than right dot first, then we have to return whatever to return, since left is having the depth more. So if you increase the depth, left dot first plus 1, we have to do left dot first plus 1 comma the root, the left one, right? So if right dot first is greater than left dot first, we have to return right dot first plus 1. This is the depth of current node, and right. So finally we have to return, so if both are equal, so if left depth and right depth are equal, we have to return the current node. So the depth of the current node will be any one of that whole right left dot first, and we have to return the roots itself. So this will give corresponding root. So here we have to just return work of root dot second, we have to return, because second will give the root of it. We will run it and we will see it whether it is working or not. So there is a compilation error. Okay, there is a compilation error. So here you can see left dot first plus 1 or left dot second, we have to return the code. This is the right dot second. So let's run it again. Okay, there is some wrong with this. Let's see what is the wrong with this. So this one you have to increase the depth, right? So let's see. So it is giving the correct outputs. Let's submit it. So it is giving the correct answer as well. Okay. Okay, thank you.